the other important element in your project is the drainage. You have a drainage drawn in this area.
Correct.
And in the project as you had it, it did not function. The fact that it did not function could be seen from the fact that there were no arrows drawn in this drainage if and when water was actually in your project and rising. And when a water overlay calculates, it also produces a result called the object flow output. Every object through which water flows has an object flow output. And those were all zeros, which means for every time frame there was 0 water flowing through, which means it doesn't work. What's important is that A, your groundwater level is configured appropriately, and B, your drainage is configured appropriately. For your groundwater, I want to emphasize we have a groundwater configuration and we have a number of default groundwater geotiffs available with which you can already create a approximation of what relevant groundwater levels would be for any given area in the Netherlands. It's a rough data set, but it is a data set. These values are provided by the NHI, for which I forgot what the acronym actually stood for. And they are values which say as much as lowest groundwater level, highest groundwater level, average groundwater level. They all have particular and special meanings in the water world, or in the expertise field of hydrology. But it's important to emphasize that GLG, GHG, and GVG mean as much as what the distance is between the terrain height or the surface of the terrain and the actual groundwater level, i.e. how deep is the groundwater. We have 3 options here that you can select with which to configure the initial groundwater situation. You can say do nothing, which means, well, do nothing, basically just listen or extend the water level areas through the underground. We have a groundwater depth geotiff and we have a groundwater level geotiff. The level means relative to datum and the depth means relative to surface. So you can imagine these geotiffs, they are actually meant to be used in the depth mode. They're relative to the surface. They have values for maybe about a meter max in terms of depth. So water level being a meter below the actual ground, the actual surface. And you have a project area which is at about 22 meters relative to datum. So 22 meters high. That means it's a big difference whether you interpret this as the depth or the datum. And for you, it was set as the datum, which meant that the groundwater level was set at 1 meter relative to datum, or 21 meters below the surface. That is, to say it mildly, deep.
Yeah.
It should have been set to the groundwater depth to initialize it properly. After setting it to the depth and then recalculating, it's then also possible to create a measuring line. Say you want to read out the groundwater table. So this is the height of the groundwater relative to datum now in this section of the project. Mm-hmm. So the geotiff is configured to be interpreted as the depth. That's fine, that's correct. The groundwater table output shows that result relative to datum. So this is at a height of 21 meters relative to datum. The ground height is about 22. So this is where the groundwater level sits. And the good part about this is we have that groundwater table and you can compare that with the surface lost value relative to datum. And as the simulation then progresses, that groundwater level relative to datum and the water level relative to datum, you can actually see those interacting with each other. So at the beginning of the simulation, the depth of the water is basically so deep it equals the groundwater. But as the surface water level increases, at some point it will be so far above the groundwater level that it actually starts to affect the groundwater level. And you also see the drainage activating at some point.
Yeah.
For the drainage, I'll explain that in my next paragraph. But what's important is if you want to see how the surface water level and the groundwater level relate to each other, whether those are actually sensible values, because that's what put me on the track of, hey, the groundwater level is particularly low. You can compare the groundwater table and the surface loss value relative to datum, and you will see those two values in a graph, and you'll be able to get some feeling of where they relate to each other. So far, so good?
Yes, it's clear.
Marvelous. Then the final bit is there is the drainage configured here. Drainage is still a bit finicky in the platform. I'm comfortable saying that. It does take a correct configuration to get it to work, but it's not actually all that strange of how it needs to be configured. First and foremost, the polygon with which it is drawn must be specifically two separate shapes. It must be one construction, one feature, but it must be two shapes, two separate polygons.
Yeah, I saw that in the wiki also.
Yeah.
That you have one do in the waterway and one in the field.
Exactly. One under the land and one in the waterway. And what's important is that the two are not connected. The way that yours were drawn, they were very close to each other, particularly here. I'm not sure if the polygons as vector data touched, but there was a chance that perhaps in the process of rasterization, so turning those vectors into grids, perhaps they were interpreted as touching and therefore led to an interpretation issue by the water overlay. I cannot be absolutely sure of that, but I have increased the distance between the polygon in the waterway and the polygon under the land, just to exclude that possibility a bit. What I've also done is I have added a drainage datum attribute. It is an attribute that indicates at which height the drainage is actually positioned or interpreted to be positioned. I will say, when you asked this question, I reviewed the documentation and I did indeed find that there was one note missing from the documentation stating that the drainage datum for passive drainage, as we have here, is actually required, because the drainage datum dictates both the height at which water can flow in on the water side and the height at which water can flow in on the groundwater side, and also can flow out. And if it's not present, it is interpreted as being very low, which means that in theory, yes, water can flow in very easily, but it can't actually flow out because it's also very low on the other side and there's water above it.
Yep.
So you have a flooded drainage and that doesn't communicate water anymore. For active drainage can actually force more water one way or the other, even when the water level is above it. But for passive drainage, the drainage datum is required to be a valid value. So we've added that note. And I've also added that to this setup. I've placed it at 22.9 meters. And as the simulation progresses, I need to switch to the overlay again. As the simulation progresses, the water in the, well, it still has my legend selected. There we go. So I have the waterway again. It still has that selection. I don't want that selection legend there. this work? There we go. Redraw. I select the surface loss value relative to datum again. I select the groundwater table again. I showed in relative mode because then the differences are more pronounced where they need to be. Mm-hmm. As I play the overlay, the water level increases. It exceeds 22.7. It's very close to the 22.9. At some point, it reaches the 22.9, and at that point, it actually starts to flow into the groundwater through the drainage, rather than fill up the waterway further. Yeah. So that is the drainage actually functioning. Mm-hmm. While the water is below the level of the drainage, it's in the waterway. As it reaches the drainage will start to function and will, in this setup, actually cause water to flow into the underground because they're just hollow tubes. It can flow either way. Yep. So that is what is necessary for your drainage to function correctly. The groundwater geotiff needs to be correctly selected as being depth, not relative to datum. Mm-hmm. Your drainage polygon, just to be sure, should be a bit cleaned up, that there's a bigger distance between your two shapes. I'm not sure if it needs to be this excessive, but well, you see it functioning right now. So
yeah, better safe than sorry.
Exactly. And 3, it needs a drainage datum set because it's passive drainage. It needs to know at which height water is communicated from one side to the other. Yep. I think those are all the bits and pieces that you need to resolve your question.
Yeah, I think so too.